Hello everyone, myself Jagat Kumar and I am here to explain about the pre-tensioning and post-tensioning of concrete. Pre-tensioning and post-tensioning are the types of pre-stressed concrete. First, let us know about what is pre-stressed concrete. Concrete in which reinforcing steel bars are stretched and anchored to compress it and thus increase its resistance to stress is called the pre-stressed concrete. The pre-stressed concrete, the reinforcing steels are stretched and anchored to compress it so that the initial pre-stressing initial compressive force is incurred into the concrete. Now let us look into the main difference between reinforced concrete and pre-stressed concrete. Both utilizes the structural capabilities of steel and concrete. Concrete is very strong in compression but relatively weak in tension. Ordinary reinforced concrete. Beam supports a load by developing compressive stresses at the top, but since the concrete cannot resist the tension at the bottom, it cracks here. Reinforcing steel bars are placed within the tension zone to resist the tension and controlling the cracking. As we all know that concrete is strong in compression but weak in tension. To compensate this, reinforcing steel bars are provided in the tension zone to increase the tension properties of the concrete. Pre-stressed concrete. It involves the application of forces tending to bend and compress a concrete element in order to counteract bending which results from the loading. As we all know, upon loading the concrete, it will bend so that to counteract the tensile forces, bending forces, we initially apply the compressed stresses before loading the beam so that the initially uh, initially provided compressive force will be counteracted by the tensile forces. The force applied is the tensioning or stretching of the steel component, which usually in the form of high tensile strands, wires, or bars. Here we can see the reinforced concrete, pre-stressed concrete before loading, and pre-stressed concrete after loading. Pre-tension and post-tension. These two differ in the method of stressing the elements. A description of the construction sequences will help bring out this difference. The below image here we can see the pre-tensioning and post-tensioning process of the pre-stressed concrete. Pre-tension, pre-stressed concrete. The beams or elements are constructed on a stressed bed and strand cable is placed between two buttresses anchored and stressing bed which holds the force in the stretched cables. After stretching the steel with hydraulic jacks, concrete is placed in forms around the cables and allowed to harden. When the concrete reaches sufficient strength, the pre-stress force is transferred to the concrete by bond when the steel strand and the end of the beam is cut loose from the buttresses. In this image, we can see the process of pre-stressing of the concrete. Upon the pre-stressing bed, the end abutments, jack, and the steel tendon are placed. In the first process, applying of the tension to tendons, where jack are used to provide stress to the steel tunnels, which are pulled upon. And in the second process, the casting of concrete will happen. The mold is placed, and into the mold, the concrete is poured and casted. And finally, transferring of pre-stress by cutting the tendon. This is the tensioning device used for the pre-tensioning of the pre-stressed concrete. And now let us look into the post-tensioned pre-stressed concrete. Post-tensioning is a technique for reinforcing concrete. Steel cables inside plastic ducts or sleeves are positioned in the forms before the concrete is placed. Afterwards, once the concrete has gained the strength, the cables are pulled tight and anchored against the outer edges of the concrete. Basically, the main difference between the pre-tension and post-tension is that the pre-tensioning, the steel tendons are tensioned before the casting of the concrete, and in the post-tension, the steel tendons are tensioned after the casting of the concrete. Now let us look into the process of post-tensioning. First one is roles of post-tensioning cables. In the first process, we will take the post-tensioning cables, and in the second process, pulling the anchors for post-tensioning cables. We will pull the anchors to the post-tensioning cables, and in the third process, Positioned post-tensioning cables. We'll position the post-tensioned cables. The fourth process, post-tensioning cable ends extending from freshly poured concrete. And in the final process, hydraulic jack are used to pull the cables so that tension is provided to the cables. Pre-tensioned pre-stressed concrete is usually fabricated away from the job site in a pre-stressing plant, whereas in post-tension pre-stressed concrete, the application of stressing forces to the structure is done at the job site. Mechanical devices. Now let us look into the tensioning devices. Firstly, mechanical devices. The mechanical devices generally used include weights with or without lever transmission, gear transmission in conjunction with pulley blocks, screw jacks with or without gear devices, and wiring winding machines. These devices are employed mainly for pre-stressing structural concrete components produced on a mass scale in factory. Second, hydraulic devices. These are simplest means of producing large pre-stressing force extensively used as tensioning devices. Electrical devices. The wires are electrically heated and anchored before placing concrete in the mold. This method is often referred to as thermo pre-stressing and used for tensioning of steel wires and deformed bars. Chemical devices. Expanding cements are used and the degree of expansion is controlled by varying the curing conditions. It's the expansive action of cement. Let us look into the advantages of pre-stressed concrete. Low construction costs. Thinner slabs, which are especially important in high-rise buildings where floor thickness savings can translate to additional floors for the same or lower cost. Fewer joints since the distance that can be spanned by post-tension slabs exceed that of reinforced construction in the same thickness. Longer span lengths increase the usable unencumbered floor space in buildings and parking structures. Fewer joints lead to lower maintenance costs over the design life of the structure, since joints are the major locus of weakness in concrete buildings. Disadvantages of the pre-stressed concrete. The major problem with pre-stressed concrete is that it needs specialized construction machineries like jacks, anchorage, etc. Advanced technical knowledge and strict supervision is very important. For concrete pre-stressing, high tensile reinforcement bars are needed, which cost greater than generally used mild steel reinforcement bars. Highly skilled labor is needed for pre-stressing concrete construction. These are the disadvantages of the pre-stressed concrete. Thank you, Nindal.